Hello and welcome to my YouTube channel. This is my first ever video on optics. Hopefully this will be the start of a long MCAT prep series where I can go into depth on some high yield biochem, and chem phys topics. But today I want to begin by discussing optics and specifically the general intro into the concept and how you might end up seeing it on the MCAT. When we talk about optics, there's two main things to focus on, and that's mirrors and lenses. However, the MCAT has a tendency of focusing more on lenses than they do mirrors. So I'll go through both of them, but I want you guys to focus more on the lenses topic, as you might see that more often than the mirrors. So let's get started. So when we talk about mirrors, I'll just highlight it here. There's two main types of mirrors, concave and convex, just as there is lenses. So when I think of concave, I'll write that here, concave. It's basically like a cave. It looks like a cave. So it looks like that. And when light rays come in, regardless of where they touch on that mirror, they're going to reflect back onto a specific point. So as we see these two light rays, they came in from different angles, both touching that mirror, and reflect back onto a specific point. This specific point that we see here in blue is our focal point. And the distance from that point to the start of our mirror is our focal length. So I'll write that here, focal length. And this is the basis of a concave mirror. Now let's talk about convex mirrors. A little bit different. Convex mirrors. So let me draw that principal axis here. And a convex mirror looks the opposite of a concave mirror, right? So basically for this, the light ray comes in, and instead of reflecting to a specific point, it kind of reflects oppositely, right? So instead of those two things converging, they're diverging into different areas. They'll never, these two light rays here, this number one and this number two, will never touch, right? They'll just be kind of diverging in their own separate ways. However, this focal point still exists. It just has nothing touching it. So these two focal points on either side still exist, same as here, right? But as you can see, for a convex mirror, those light rays are diverging. So that's why convex mirrors are also known as diverging mirrors. Diverging mirrors, because if you can see here, the light rays are diverging. And similarly, that's also why concave mirrors are also called converging mirrors. Converging mirrors, because as you can see, those light rays converge to one center point. And for a convex mirror, those light rays are diverging their own way. Something that's also important about mirrors is that they have a radius of curvature that's very unique to mirrors. So let me draw out another principal axis, and let's just say we have a concave mirror here with our blue focal point here. And basically what our radius of curvature is it's double. Let me draw that in a different color so you can see it better. It's double the focal point, or the focal length, excuse me. So if the radius of curvature is equal to 4, that means that let me draw this in blue. That means that our focal length is 2. So based on that relationship, we can say that, and you can either see the radius of curvature as C, or I've seen it before as R. So regardless of how you see it, just know that the radius of curvature, so in this case we'll just write it R, the radius of curvature is equal to 2 focal lengths, right? And that's an easy relationship to understand. It's double the focal length, right? So yes, that's the basic understanding of mirrors and the two types of mirrors. Just knowing, again, why a concave mirror is also a converging mirror and why a convex mirror is a diverging mirror is important because you know how those light rays will interact with those specific mirrors. All right, so enough about mirrors. You won't really see them much on the MCAT, but it's good to understand them so you can kind of distinguish between those two and the difference between mirrors and lenses. So now let's talk about lenses. You pick a different color. Let's pick this purple color. It's nice. So for lenses, there's also two types of lenses. However, let's see if you can figure out what the difference is between what we just talked about with mirrors and lenses. So our first lens we can talk about is our concave lens. And similarly, it's a cave. It looks like a cave. However, now we have two, right? So it'll look something like this, kind of like an hourglass shape with this line of symmetry in the middle. And so for our light rays, remember, mirrors, we said, reflected light. So optics and lenses in general refract light, not so much reflect. So let me write that here so you can understand that. So we can say lenses refract and mirrors reflect. Very similar words, but very different as well. So let's go back to our concave lens. When that light ray comes in, it'll hit that lens and it's going to diverge out. Similarly, hits that lens and it's going to diverge out. And again, these 2 points, these two light rays will never converge together. And that's the difference between a concave lens and a concave mirror. In a concave mirror, those rays converged, while in a concave lens, these light rays are diverging. So a concave lens will also be known as a diverging lens because when those light rays touch that lens, they're going to diverge. So now you probably figured out the pattern, but if we talk about a convex lens, it'll look something like this, right? Remember the mirror looked like that, but now remember we add another one, and it'll look something like this with the line of symmetry in the middle. And similarly, if we have some light rays come in, regardless of where they're hitting this lens, they're going to converge to one spot. So let's just say they converge to this spot. This spot, again, is our focal point. And this distance, nothing changes, right? It's still our focal length. So I'll just put it here as f length. And we can also have focal points and focal lengths on a concave lens. I think the biggest thing to realize between these two lenses is how these light rays are interacting with the lens. Here on the convex lens, we can say that they're converging. So we can label that converging rays. And that's why convex lenses are also known as converging lenses, right? So understand these relationships between the two. And I think it's also important to know that MCAT is going to always quiz you, or almost always quiz you, on convex lenses because the human eye itself is a convex lens. Just pretend that's an M. Human eye is always a convex lens. So you might see a little bit more questions on convex lenses than concave, but it's important to know both of them. So now I want to talk about the relationship. What kind of questions you might see and how do you solve for these different things. So let me erase this. Hopefully you have this jotted down or understand the basics of these two types of lenses. So now let's talk about the relationship. Well, there's a widely known equation, this thin lens equation. Let me write it in a nice green color. So write it down here as our thin lens equation. Well, what's our thin lens equation? It's 1 over our focal length is equal to 1 over the distance of the object, or d sub o, plus 1 over the distance of the image. right? So our distance of image and our distance of object. I haven't drawn any objects yet, but let's just say we have this principal axis. We have, let's say we have a lens here, and let's say our object, which is almost always drawn as an arrow. Let's pretend this could be a tree, this could be a snowman, whatever you want it to be, but that's going to be our object. So easy to understand, the distance from our object to our lens is the d sub o, and then let's pretend our focal point is here somewhere. This distance from our focal point to the lens we already know is our focal length. So let's write focal length. And then for these lenses, remember, light ray comes in. It's going to converge into one specific spot. And we'll learn more about how to draw these later on, but basically these light rays are going to meet, and where they intersect, that's where your image is going to be created. And so this image also has a distance away from the lens. Well, that's your distance of the image. And so that's how you can plug these numbers in and solve for one, or plug them in and solve for a specific value, right? So now you may also be wondering, how do you figure out what the values are? Is focal length negative? Is it positive? Is the distance positive or negative? Because that can definitely interfere with your product, right? So let's go through these relationships real quickly. I'll leave the equation there. Let me just rewrite this. DL, right? Perfect. So focal length, let's pretend that says focal length. I'm sorry I draw my F's like that. Your focal length depends on the type of lens you're looking at. So for a concave lens, your focal point is going to be negative, or your focal length, sorry. For a convex lens, well, you might have already guessed it, it's going to have a positive value for your focal length. And that's just basically dependent on the lens. So your focal length is dependent on the lens. So that's the length. Your distance of the object is always going to be positive, regardless of the lens type. So always positive. And then finally, your distance of your image depends on the orientation of the object to the image. So remember, we had let me just draw another principal axis, a convex lens, sorry. And let's pretend our object is here and our image that we drew last time was here. If your image and your object are on opposite sides, then your DI value is going to be positive. However, if they are on the same side, as you can see here, then your distance of your image is going to be negative. And this really comes into play when you talk about magnification, right? So magnification, really quickly, we'll label it as M, is just equal to the ratio, the negative ratio of your distance image over your distance object. So as you can imagine, if your distance image is negative, so if this is on the same side as your object, then you're going to have a positive magnification because these two things will just cancel out. However, same thing, if your distance image is positive, if it's on the opposite side of your object, then you're going to have a negative magnification. And so that's how these two things come into play. So I'm running out of time now, but on the next video, I'm going to go over all the possible combinations you might see on the MCAT, as well as I'll go through 2 or 3 examples of practice MCAT questions.